Yes, coming to the advantages of steel structures, see, these all are, these are plenty of advantages of using steel as a structural element, right? We'll see one by one. So the first one is like, as you know that steel is very is having a very high strength to weight ratio, which means the dead weight of the steel structure is relatively small. So this property makes a steel a very attractive and structural material for some for multi-story building and for long span bridges, right? So thereby, so it is having a one advantage, which means that it is carrying the strength carrying capacity is high. Simultaneously, the dead weight of the material is less, right? So this is what the very most important advantages of steel structures. Uh, Next, coming to the uniformity. As we know that in RC constructions, we are using concrete and steel, right? Concrete and reinforcement bar. So there, even though it is a combination of two more material, but we are assuming as a homogeneous, right? But but when you take a steel structure, it is completely made up of a steel only. It is a uniformity. We are having very good uniformity so that the proper load transformation will takes place since it is having a uniformity and simultaneously elasticity. As you all know that the steel is very ductile in nature, right? Are you do you believe this? Steel is good at ductile or tensile in nature? Yes, please. So since it is ductile in nature, so the main advantages of having ductile in nature is like it will undergo the plastic deformation before failure. Do you know that in RCS class we have discussed if at all if you are not used any rebar or reinforcement in a concrete structure, what happens if load is applied on a particular member, since it is made up of only a concrete, so then there will be a compression, I mean brittle in nature, since concrete is good at compression. So if for that member is subjected to any tensile stresses and all, that material is not able to withstand the tensile stresses, so thereby what happens, suddenly it will collapse. So in order to prevent that, the reinforcement or rebar is introduced, so thereby to prevent the tensile stresses, right? So if what happens by introducing a steel or rebar, so it instead of sudden collapse, it will give you a warning in the form of a large deflection or certain cracks, right? So thereby we can come to know so that the structure is going to fail. So this is what the main advantages of steel, which is having a very ductile in nature, right? And that the thing is that it will give you, I mean, it undergo the plastic deformation. Plastic deformation is nothing but enlarged deflection or enlarged deformation. So this is what the advantages of steel structures which we have, right? Next, coming to the long lasting. Long lasting means, see, these steel structures are very longer durable structures, right? Longer and durable structures, which means that if you compare with RCC, so the steel structures are very durable. Why? Because we can give nowadays the RC structures we can give up to a period of 30 to 40 years. But when you take a steel structures, we can assure, I mean, we are assuring that more than 50 years because the steel is made up of completely very high good material, right? And which is having high strength, uh, which is having a homogeneity, uniformity, elasticity, everything. So because of these all properties, right? So we can guarantee that the steel structures are long lasting, I mean durable structures. Even the steel structures are built with very high quality relationship. This is very important. The steel structures are built with very high quality relationship. So that is very important. Quality is important. Otherwise what happens, see, in RC structures you take, so there the people, the labor people are involved in making a construction there, so there is a chances of doing mistakes and errors are more, right? But whereas here, so the completely in these type of structures skilled labors are involved. So the, and that too the work by the people is less, only they will take care about the connection, because the structure, the members, whatever the beam or the columns have been already pre manufactured, right? So manufacture, just the only thing is that directly we are just taking that element and then we are fixing at the particular, we are taking at the site and then fixing at the particular structure, a particular joint, right? So thereby we are assuring very high quality relationship and then very narrow tolerances, right? So this is also one of the very good advantages of steel structures. Next, coming to the next advantage is like the prefabrication and mass production is most possible. Yes, see, normally, as I just now I said about uh, the steel structures, or these steel elements, steel members are manufactured at the before the construction itself. I mean, prefactured, prefabrication, we can say, right? So generally these steel elements are done at this type only, right? So once the steel members have been cast, and then directly it is taken to the site and then they will erect the structure, right? So that is what this is only possible with steel only, the prefab. And sometimes when you take industrial structures and then high-rise structures, so the production requires a very high requirement, right? So that's why, so that is possible with the help of a steel, right? So this is also one of the very good advantages of steel in using its structures. Followed. Next, coming to the rapid speed of construction, and then rapid construction is possible in steel structures. So this results in economic construction, right? So wherein which, see, if the speed of construction and then ease of construction results in economic construction, obviously, right? But when you take RC structures, so we need to wait for 28 days, right? For the curing and for to gaining the strength. But whereas since the steel have been prefabricated already, so directly just taking them at the site and then joining the fixing the materials, right? Fixing the connections. So thereby, so the since because of this process, the speed of construction will also be very high, and then easy, the connection, the ease of connection is also good. So because of these, it results in economic construction. Followed. Next, coming to the ability, next advantage is like ability to be rolled into various sizes and shapes. Yes, this is very important. See, we can have, as I said just now, the steel structures are prefabricated at the site, at the site itself. I mean, we can have different shapes and different sizes. That is very important. We can call rolled steel sections, right? So which are directly we can say that these standard sizes and shapes of steels are already available in the market, right? So directly we can purchase it and then we can use the use for the construction, right? So that is what, since it is very ductile in nature, right, tensile in nature, so that we can make into any shape and any size, right? So that is very important. And as you know that the steel structures are having very good fatigue strength. Fatigue strength means, so since it is if you subject it to number of repeated loads, so it will withstand, definitely it will withstand, and it is showing a very good fatigue strength against the load. And one more thing is like the steel structures can be strengthened at any time for in the future if necessary. See, say for example, you initially are constructed with some member, some, say for example, one size, you take I section column and then I section beam, you have made you made one building, right? After 10 years or after 20 years, if you want to go for another some more floors of construction, to increase the floors of construction, so there you need to strengthen the element. Strengthen the element means you need to strengthen the column as well as beam. So what you have to do, you have to join the another member in adjacent to the column, right? Similarly to the beam, right? So likewise, that is possible only in these steel structures. Whereas, is it possible in the RC constructions? Strengthening of element, I mean, by the adjoining or by fixing the one more material to the adjacent to the concrete? No, it is not possible. Why? Because initially, once it is constructed, it is over. It is enough. That is the first and final. But only thing that we can do retrofitting, but we cannot make a high strengthen as it is required, as it is essential, right? So that is only possible with the steel structure, so that it can be strengthened at any time if it is required. Followed? And one more, so one more last advantage is like the steel structures are having a reusable capability, reused capability, which means so we can use, after certain years, say for example, the steel structures, whatever the waste materials can be recycled, can be reused further. It won't go waste as like a RC. You just RC structures you just take. So that is demolition waste or construction waste you just see. So that is used only for the unimportant works like compounds and some bed concrete and all. So those things they can use in as far as RC structures are concerned. But whereas the steel structures, by doing modifications, so that we can use reuse further in the construction. So it is having a reused capability. Followed? All of you? Did you understand these all advantages? Around 8 to 10 advantages. Yes, please. Have you followed?
Yes, sir. Yes, sir.
Okay. So briefly, you just note down the points also simultaneously while I am explaining, right? You just note down the terms: high strength per unit ratio, per unit weight, uniformity, elasticity, long lasting, ductility, toughness, easy connection, speed of. So likewise, what happens with the help of these short terms, you can able to explain in a better manner, like how I explain now with the help of these things, right? So this is enough as I mean this is a good number of advantages of steel structures, right? Now coming to the disadvantages, as I just now I said, steel structures are having certain disadvantages, very few disadvantages, but only thing that we have to take care, that is as you all know that the maintenance cost, definitely since the skilled labor is required, but obviously the maintenance cost. Why? Because so there is a chances of getting corrosion and all. We need to do some painting, or like not to corrode, have to give certain remedial measures we need to take, right? So that is what some maintenance costs is required, so that we have to ensure as per as these steel structures are concerned, right? And one more thing, so these steel structures are costly compared to the any other type of structures. This is one of the disadvantage. Why? Because see, as you know that when you compare with RC and steel structure, RC you just compare for one for any 1 meter cube of construction, or for any one structure you just compare. So the steel structures are high cost. Only thing that we have to bear the cost. That is one we can say that we are taking into a disadvantage part. But as per as the strength point of view, since it is a requirement, since it's the essential point, so then we need to no need of worrying about the cost point of view, especially in industrial buildings, in high-rise buildings and all. There the cost matter is kept aside, right? So only they will worry about the strength point of view, right? So if you taken care, if you are agreed with the cost point of view, then it is a very good type of structures, as in steel structures as a construction material, right? And then next, the strength of the steel is reasonably reduced or considerably reduced when it is subjected to fire protection. So we need to, I mean, even though we can do the fireproofing, but even then, when it is subjected to fire, high temperature, or high fire of more degrees Celsius centigrade. I mean, when the building is subjected to fire, so there is a chances of getting these elements subjected to what we call the strength will get reduced when it is after subjected to fire, right? So that also we have to ensure, and you have to take care our steel structure should not subjected to fire. And then next, fatigue, as I said just now, it is a good fatigue strength, but even then if it is subjected to number of loads, number of times, so less fatigue strength uh, compared to the other type of structures, right? So this is actually, fatigue is not that much disadvantage because it is having a very good fatigue strength, but even then our structure should not subjected to number of times. I mean, as I said just now, reused, no? So that type we should not do it. Once, twice, thrice, okay, but number of more than third time, fourth time, again that leads to reducing the strength, right? And next, coming to the one more disadvantage, that is steel structures when it is exposed to air and water, especially in bridges. When you take in bridges, so there is a big possibility of getting corrosion. That also we have to ensure. I mean, so since it needs a regular maintenance, right? So that also you have to take care. And then next last point, that is brittle fracture. See, since steel is made up of very, I mean, ductile material, but even then, sometimes what happens, there is a chances of getting a fracture, brittle fracture in the steel element. So this is very rare, but even then, so this also is considered as one of the disadvantages of a steel structure. Followed? All of you followed? Yes, please. Okay. Next, coming to the use of steel structures, where we just now I said no, where we can use steel structures. Can anyone please tell me use of steel structures where we are used? Yes, please. Use of steel structures. Applications. Yesterday I discussed no. Yes, tell me. Long span structure. Correct? No. Please, you keep on say. Just I will type here long span structure, because you need to remember these things. You have to explain. You should be able to tell the applications of steel structures. Next, high-rise buildings. Yes, please. Next,
Bridges.
bridges. Right. Next,
Residential buildings, sir.
residential buildings we will not use. Residential buildings we will not use. Huh? Towers. Yes. Skyscrapers. Right.
Sir, metro stations.
Metro stations. I mean, industrial structures. Right. Next.
Garages, sir. Parking garages.
Industrial parkings, garages. Right.
Railway steel structures, railway bridges.
Trusses. We can say trusses.
Yes.
Trusses. So when I say trusses means it includes all railway platforms, wherever trusses are there, no? So in a multi-storied building, so it all covers different types of trusses, right? So these are the most common types of structures. Yes.
Steel bridges, railway steel bridges.
Yeah, here I use no written already bridges, steel bridges.
Yes.
Okay. So these are the most common types of structures which are by using as a steel structures, right? You should remember, and then you should be able to tell these structures. Okay, fine. So once after finishing of these advantage, disadvantage, and use of steel structures, so next thing is like you should know about the stress strain curve. I think you already know in strength of materials, in SA, in RCS, you already studied about the stress strain curve, right? So for mild steel and all, right? So this is what initially there is a I mean from here to here it is a up to yield point, that is elastic in nature. After that, so this portion is called as what we called a plastic region. As I said just now, the steel structures will give can undergo plastic deformation before collapse. So this is what the plastic region, right? After the yield point, so the plastic, it will enter into the plastic region. There in which plastic is nothing but the kind of a permanent deformation, right? Up to here, if you remove the load, it will comes to original position, right? But after this point, if you remove the load, the material will be I mean deformed at this level, at this stage only, whatever the value it gained, right? So that is what permanent kind of a permanent deformation, that is called as a plastic deformation. After that, when it is subjected to further loading, it leads to a maximum ultimate load point, that is breaking maximum. It will reach to a maximum point, and then thereby it leads to failure at this point, breaking point, right? So just I have a glance of this stress strain curve for a mild steel, right? So and then we'll go to the next. Next is like a limit state. As you all know that earlier we have the design practices like working stress method and then limit state method, right? So nowadays, are we using any working stress method for the design? Yes, please. Are we using nowadays any working stress method for the design, even RCC or steel? Go back to the RCS structures. So they're also the same concept. Limit state method. See, working stress method is having more disadvantages, right? So we had three design philosophies. One is working stress method, another one is ultimate load method, and then third one is limit state method, right? So since in working stress method, there the material strength performance is not guaranteeing the any strength performance, and then leads to uneconomical structures, right? So it is only taking care about the material strength, not at all worrying about the loads, right? And then in ultimate load method, there they are concentrated only about the loads. They are by multiplying the partial safety factor, and then there the ultimate load method does not guarantee any the material strength performance, right? So because of these all demerits and drawbacks of these two methods, so limit state method is developed. That is a combination of both the strength and serviceability, right? So that is what the limit state method, right? So when any structure or structural element becomes unfit for its intended purpose, it has reached or exceeded a limit state. This is what the definition of a limit state. As you all know that there are two types of limit state. One is limit state of strength and limit state of serviceability. Correct? In IS 456, even in IS 800 also, we are having the same limit state methods or limit state this thing. Okay, followed all of you? As you know that limit state of strength, strength limit state means what happens? So what are the possible case of strength limit state? There is a loss of equilibrium, loss of load bearing capacity, spread of local failure, very large deformations. I mean, these are the failure when it comes to a limit state of strength, right? When it comes to limit state of serviceability, what are the failures? Excessive deflection, excessive local damage, unwanted vibration, right? So keeping into consideration of these all failures, so our structures have been designed for the limit state of strength and then limit state of serviceability. Like how we are followed in RC structures is, so the structures are designed for strength, limit state of strength, right? And then it is checked against the serviceability. So similarly here also we are doing the same process, right? Same procedure. Followed? Yes, please. Hello. So you just have a look into about the these design philosophies. Same like in RC structures, like what you have studied, the same thing. Even for steel structures also, it is same thing. It is applied. Just go through it once again, right? So I will share these notes, everything, right? Next, coming to the next. Can you see this PPT? Another PPT. Hello.
Yes, sir. Yes, sir. You can see.
Okay. Now then the next thing is like rolled steel structures. This is one more important topic. So I will cover this and then I will wind off this after this. Okay. So as I said just now, in advantages we have taken one point, that is the steel structures can be can be made into any shape or any size, like called as a rolled steel structures, right? So this is what the rolled steel structures, which means that, so these are the standard available sizes of the steel structures which are readily available in the market. Directly we have to purchase it and then we have to use it for the construction. But how these rolled steel structures have been manufactured and what are the sizes, what are the shapes, that we should know it, right? Like concrete, steel sections of any shape or any size cannot be cast inside. Like in concrete, we are based on the formwork size we can cast, but steel structures we cannot do it. The steel is having certain sizes and certain shapes, right? So steel needs a very high temperatures to melt and to roll into required shape. This is very important. So that required shape means, so the steel structure sections of standard shapes, sizes and length are rolled in steel mills, and these are the various types, right? These are the various shapes of a steel sections. Initially, when I'm using the term rolled, means it is already manufactured at the site by making a process of heating, melting, right? So these are the things. That's why always we'll use rolled. The word rolled means it is manufactured, right? It is made subjected to very high temperature and melt and then rolled means given a proper shape. So that's why in almost all types of sections we are using the word called rolled, right? Rolled steel I section, rolled steel I section, which is generally I in shape, correct? Next, rolled steel channel section. Channel section means I will show you the images also, right? And where we can use these shapes also, right? But as of now, you just know this, the different shapes. Next, rolled channel means C shape. Next, rolled steel angular sections. Angular sections means L type, right? Angular means L type. Next, rolled steel T sections. T sections means T in shape. Rolled steel bars. Bars means either we can have rounded bar or square bar. Anything we can have, right? Rolled steel tubes. Tubes means hollow tubes. And then rolled steel plate. Plate means as like a normal rectangular plate or square plate. Rolled steel flat. Flat means a kind of a, the difference between plate and flat is, so in plate there is a considerable thickness, whereas in flat there is no, there is no, the thickness is usually neglected, right? Flat, they are worrying about only in the length and width dimension. Rolled steel strips, kind of a strips of width like 6 mm, 10 mm width, right? So length and width is the major parameter, and thickness is negligible here in strips also. So these are the 8 to 9 different shapes of steel structures which are available in the market. Coming to the size, what size? I section, simply I said I. What are the sizes? I mean, we should see about the size. What is the depth of the section? What is the width of the section? Since we are saying we are taking as I section, no, there should be a flange and a web, right? So that we will see it one by one, right? So first that is rolled steel I section. Have you seen this rolled steel I section? In rails, in railways, in rail, this is also one of the I section, right? But this not only in the rails, even in buildings, in trusses also we are using this I section. But generally just observe, this is the what the rolled steel I section. Again, in the rolled steel I section we are having different shapes, different this thing, ISJB, ISLB, ISMB, and one more ISWB. One more, that is ISWB actually.
Sir,
Yes, please.
the slide is not changed, sir.
Slide is not moving.
Not
You are
changed, sir. In
now
limit states it is.
in limit state only it is.
No. Yes, sir.
1 second, 1 second. Just now I asked, no, you said yes, it is visible.